functions and inequalities. You should view these notes after you've completed the 4A Discovery worksheet. Alright, some summary information about graphing quadratics. The general form of the quadratic equation is y equals a times x minus h squared plus k. The vertex is going to be hk. H moves the graph right or left. K moves your graph up or down. A changes the width of the graph. And if A is negative, then the graph is flipped. You should recognize all of this. It's very similar to what we did when we talked about quadratics, or talked about absolute values. Now we're talking about a quadratic or parabola. So A, H, and K do the same thing to a parabola as they did to the absolute value graph. So let's look at an example. All right, probably the hardest thing on graphing these is that vertical stretch. All right, let's start off by graphing y equals x squared. This is the parent graph. So here x squared. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. These are your parent points. You need to memorize this pattern. We can no longer treat A as slope as you did an absolute value. Okay, and that's, like I said, that's a very common mistake. You can no longer treat A as slope because now we have a curve, and curves don't have slope. All right, let's graph the parent graph. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So here's my parent parabola. And here, like I said, we're only graphing a piece of it. If I need more points, 3, 9, 4, 16, I can keep going. All right, now look at our first, let's graph A. Y is equal to negative 1. So that means A is negative 1. So just your Y values are going to be multiplied by negative 1. So 4 is going to become negative 4, negative 1, 0, negative 1, and negative 4. Notice we didn't move our vertex, so we're still counting from 0, 0. But this time I'm going to go left 2, down 4, because I'm multiplying by a negative 1. Left 1, down 1, 0, 0, right 1, down 1, and right 2, down 4. Okay, so here's my graph A. So a negative A flips your graph. All right, let's look at what happens when we have A as something else. Let's look at A of 1/2. All right, I still want to start off with my parent points. So I'm still going to start off with my 4, my 1, my 0, my 1, and my 4. All right, but this time we're going to multiply all these values by 1/2. So 4 is going to become 2, 1 is 1/2, 0 stays 0, 1 is 1/2, and 4 becomes 2. All right, I haven't moved my vertex again, so I'm still at 0, 0. So this time I'm going to go left 2 up 2, left 1 up 1/2, 0, 0, right 1 up 1/2, and right 2 up 2. So see how the width of my graph has increased. The vertical, we're shrinking it. The vertical distance has shrunk by 1/2. So if A is less than 1, it's a vertical shrink, and if A is greater than 1, it's a vertical stretch. And we'll practice some more of this. But here again, do not treat A as slope. All right, let's look at the following. All right, so here again, we want A, H, and K. So A is 2. My vertex is negative 1, negative 3. This is where I'm going to start counting from. I'm still going to use my parent points. All right, so I got X and Y. So negative 2, negative 1, 0, 1, and 2. 4, 1, 0, 1, and 4. You have to memorize this pattern. With all these functions that we're learning, you're going to memorize that parent pattern. All right, now this time I'm going to multiply by 2 because A is 2. So 4 becomes 8, 1 becomes 2, 0, 1 becomes 2, and 4 becomes 8. But however, this time my vertex has moved. My vertex now is at negative 1, negative 3. So this is where I'm going to start counting from. So these are not points anymore, they're counts. All right, it tells me my pattern. And that's the key to all of this. All right, so from my vertex, I'm going to go left 2, up 8. I'm stretching my graph. Left 1, up 2. All right, 0, 0, that's my vertex. Right 1, up 2. And right 2, up 8. So now here we've stretched that vertical distance. We've doubled it this time. So there's my new parabola. All right, look at this one. All right, be careful about that order, okay? So what's A? A is -1. All right, what's your vertex? All right, the K this time is just out front. So my vertex is 1, 2. All right, parent points again. And I just have these memorized. This is what your goal is. All right, this time my A is I'm multiplying by -1. And each time I do these questions, this is how I do them. Taking the time to do these parent points. You don't want to do too much in your head. All right, so the vertex is 1, 2. Now we're here, remember, our vertex is moved. 1, 2. So now these are counts. We're counting. We're going to go left 2, down 4. I'm flipping it. Left 1, down 1. 0, 0, back at my vertex. Right 1, down 1. And right 2, down 4. Now if I need more points, I can just add to my pattern. 5 points, you're trying to graph at least 5 points. Sometimes it fits and sometimes they won't. All right, that's graphing with transformations. Here again, caution you again, A is not slope. Okay, it's a factor. You're multiplying by that factor of A. All right, here's one more. So here this time my A is 3. All right, my H is 0 and my K is 1. So that makes my vertex 0, 1. Okay, here again, need those parent points. Okay, I'm multiplying by 3 this time. So 12, 3, 0, 3, and 12. So 0, 1 is my vertex. All right, I'm counting. Left 2 up 12 doesn't fit. Left 1 up 3. Okay. Right 1 up 3. Right 2 up 12 doesn't fit. So this time I can only get 2 points on my graph. But here again, it's a vertical stretch. We're stretching it by a factor of 3, multiplying all the heights times 3. Here again, make sure you have arrows on the end of your graphs too. All right, let's go backwards. Now we want to give the equation. So the first thing you should do is write down the general form. Don't forget that square. So we need to find A, H, and K. Well, H and K are easy. That's right and left or right and up and down. So this thing went right 2, so H is 2, and then down 4. A is a little bit harder to find because here remember it's not slope. So I'm going to show you 2 different methods for finding A. This method I base on my parent graph. Okay, let's look at what I have here. So here's my vertex. All right. Now, here's a point on my graph. I just need another point on my graph, a full point on my graph. Just one of them. And you can test it on the other one just to be sure. All right, in the parent graph, right 2 would typically go up 4. But what happened to our graph? We went right 2 and we only went right up. Sorry, right 2, but only went up 2, not 4. So that 4 became a 2. So A is that ratio of 2 over 4, or 1/2. So there's your A. And you can test the other side too. -2, all right, here's another point, should go up 4. But it only went up 2. So 2 over 4 is 1/2. Okay, very visual way of finding A. Okay, so now let's make our equation. Don't forget you need either y equals or f of x equals 1/2 x minus 2 squared plus 4. Okay, the other way, very algebraic method. And this will work for more complicated. Sometimes we get more complicated functions. You may not be able to do them the previous way. All right, so step number 1, we're going to write the general form. All of these start with writing the general form. All right, we need to find h and k. So in this case, my vertex, what is it? 1, 2, 3, 4, 5, -5, -2. And then I just need another point on my graph, some other point on my graph. All right, I'm going to use this one. So what's that? -3, -4. All right, see where I'm going with this? I'm going to plug everything that I have in and solve for a. It's a very algebraic method. So what do we got? You got to be careful about to plug them in the right spot too. That's the biggest mistake you can make. Don't forget to square. You want to drop that square too. All right, now I'm just solving for a. So let's do what's in parentheses first. This is going to give me 2 squared minus 2. So -4 is equal to 4a minus 2. Add 2. -2 is equal to 4a. So a is equal to -2/4, which is -1/2. So now we're ready to write our equation. Now make sure you pick up the vertex, not the xy point, the hk point. So -1/2 x minus a -5, which makes it +5 squared minus 2. There's your equation. You do need to know both methods, okay? Or at least this method. The other method is a shortcut, but everybody needs to be able to do this method because you're going to need this in your future math. All right, let's do some inequalities. You're noticing a pattern here. We're doing the same thing we did with absolute values now with our inequalities. All right, so here again, I have to decide whether it's dashed or solid. So since it's greater than or equal to, I have a solid curve. I need to graph that quadratic. So a is -1, and my vertex is -2, -1. We need those parent points. With your quadratics, you always need the parent points. All right, so -2, -1. My a is -1. So I'm multiplying all of my y's by -1. All right, remember they're counts. All right, I'm doing a solid line. So I'm going to go left 2, down 4. Left 1, down 1. 0, 0, back in my vertex. Right 1, down 1. And right 2, down 4. All right. My next point, 3, 9, is not going to fit. So remember, you need to take this all the way off your graph. But if you're too far from the edge, find another parent point. Because you want to, okay? All right, same thing with hiker dude. Y is on it by itself on the left-hand side, so this would be a mountain for my little hiker dude. And y is greater than, so I'm going to shade above his head. Or you can do the algebraic method of pick a point, plug it in, and see where it's true. Okay, so my solution set is anything that falls within that shaded region. That's going all the way off my graph. All right, let's look at one more. All right, this time I'm less than, so I'm going to be dashed. All right, what do I got? I've got a is 3. My vertex is 1, -5. All right, parent point time. You've got those memorized already. All right, this time I'm multiplying by 3. Okay. All right, vertex is 1, -5. All right, so we're going to go left 2 up 12. All right, left 1 up 3. 0, 0, right 1 up 3, and right 2 up 12. All right, it's dashed. And it's a curve, not a V, okay? Make sure these shapes are a U each time. So a quadratic shape is always a U. All right, this is a valley. So my hiker dude would be down in here. And its y is less than, so I'm shading the ground. What's underneath the curve? So there's my answer. Anything, so any ordered pair in that shaded region not on that curve would make my inequality true. All right, there's your notes 4B. If you have any questions, please ask them in class.